Hello, welcome everybody. Um, this is a test stream where I'm going to teach some programming, and the idea is to teach programming by doing a series of simple games. We'll start out with stuff that's really simple and get more complex as we go. The language we're going to use is called Go. Um, it's a language kind of sponsored by Google, but it's free and open source to use. And we're going to use, I'm going to be using a text editor called VSCode, but people following along can use any text editor they want. Probably the best way to follow along is kind of type along with me. If you have two monitors, you can do that. Um, Otherwise, you can just watch and then try things out on your own afterwards. So the only things that you need to do programming are a compiler of some sort for your language and a text editor. So if you haven't already, to get the compiler, you can go to this URL and it'll look like this, and download the installer for your operating system and install it. And for the text editor, you can use anything you want. You could use Notepad if you wanted to, or you can download Visual Studio Code, which is what I'll be using. It is also free, and it's multi-platform, so it'll work the same on Mac OS or Linux, so anyone following along can see exactly what I see. So I'm going to give you guys a minute to get these things downloaded and installed if you don't have them already. If you have any trouble, just let me know on chat and I'll try to help out. And this is what Visual Studio Code will look like when it starts up. So someone is saying the text is showing up really small. Do you have it set to full screen and it's still too small? I will look at increasing the font size a little bit. Is that better? Or maybe this? Cool. All right. So if you have the Go compiler installed, if you bring up a console, and in Windows you can do that by going to Start and type CMD for command prompt. You should be able to type Go and hit Enter from anywhere, and it should find the Go compiler. If it doesn't find that, then you haven't installed the Go compiler yet. So that's a good way just to check and make sure it's ready to go. The other thing you'll need to do is bring up your File Explorer, and we need to create a folder that we're going to put all of our code in. And this can go anywhere you want. I like to put things in the C drive. So you can right click and make a new folder, call it whatever you want. I've got one called GoPath. And then inside that folder, you're going to make another new folder called SRC. That's short for source. And then inside that, you're going to want to make a new folder, maybe call it something like lesson 1, whatever you want to use to keep track of it. So that's where you're going to kind of do today's stuff, is in that folder. And so when you've got a folder set up, you can go in Visual Studio Code. You can fire that up by going to the Start menu. You can type code, it'll find it. Click that, it'll open up and look like this. Then you can go to File, Open Folder, and you want to find that same path. So whatever path you chose, Go path, source, and I chose this Hello World. That's going to be our first project as the folder. You just select the folder and then click this button here, and you get sort of like a solution view of that folder. So this is your folder here. Right now it's empty, and we're going to want to create our first file. So you can click on this icon here to make a new file, and we'll call it hello world.go and hit enter. So now we've got a new file, and it's blank. And we're going to make our very first program, and it's going to be called Hello World, which is sort of a customary first program anytime you learn a new language. So the first thing a Go program needs is a package name. And if your program is going to be something you actually run rather than a library, it needs to be called package main. So we'll start out package main. And then a main package also needs a function called main, which is where the program is going to start. You'll see this in many languages, the convention that your main function is where everything begins. So to make a function in Go, you type func, short for function, and we have to have one called main for things to start in. So we type main, and we do open close paren, because this function does not take any arguments. And then the body of main is going to be enclosed in curly braces. And when it's done, it'll look like that. So this is sort of the shortest possible correct program you can have in Go. You've got a function called main, doesn't do anything, but it is correct. Now VS Code has a nice plugin you can add that will highlight your Go code and let you know if you've made mistakes right in the editor, and some other nice utilities. So if you go up to View and then Extensions and type Go in the search, you'll see this this Go extension that's available. It should come up at the top. All you have to do is click on that, hit install, and then when it's done, I think it gives you a little icon to restart, or you can just restart the whole program manually. And then click here to bring back the Explorer view. And you should get your syntax highlighting showing up. You should see similar colors to me. Another thing you can do, if you once you have the plugin installed, if you right-click anywhere in your code, you'll see some commands you get that are available when you're working on Go source code. And if you go here, it says Show All Commands. And then if you go down here, Install Update Tools, if you click on that, it'll start making sure that a lot of the utilities that can come along with the Go compiler are all installed and set up. And this plugin uses those to give you features when you're working with your code. So you should do that. It'll take a couple of minutes, and you can just let it go while I'm talking. Another handy feature is VS Code has an integrated terminal. That's this area down here. This is exactly the same as the console here. It's just running inside VS Code. So it can be more pleasant to work with depending on how you like to work. So if you want to use that, you can hit Control backtick, and that's the key that's on the same key as your tilde key on the upper left. That will toggle it on and off and bring your focus to it. So you can hit Control backtick and then start typing in here. Now, if you're on Windows, it's going to default to a PowerShell terminal, which is kind of weird, and most people probably won't want to use it. To fix that, you can go to File, Preferences, Settings, And for you, if you've just installed this, your settings area will just look like this. It'll be empty over here on the right. And you'll want to add this setting right here. And I'll see if I can copy and paste that into chat. So you'll want to put that inside the curly braces, and that tells the console to default to command.exe, which is sort of the normal Windows console. So if you do that, delete the current command prompt you have, hit Control backtick again, you should get the normal one. So if anyone has any trouble setting any of that stuff up, let me know in chat and we'll work through it. All right, so let's make our first program actually do something. So languages almost always come with some core libraries to do basic things, and one of those things is printing things to the screen. And in Go, the package that could do that is called format, and it's abbreviated FMT. So to include another package into your program, use the keyword import, and you have to give it a name enclosed in quotes. So in this case, it's FMT, and that gives us the format package. So all the functions that are in the format package are ones we can use now too. So if you go inside the main function and type FMT and hit dot, if you've got the plugin installed, you'll see a list of all the functions that are inside the format package that you can use. And we're going to use one called println. And this can take arguments that you can pass it. In this case, we're going to pass it a string. And you indicate that you want a string by putting things in double quotes like this. So now you can type anything you want. And we're going to start with hello world. And if you hit Control S, it'll save it. And you notice we get red squiggly lines when I saved it. So that's the Go plugin identifying that I have made a mistake. And it says undefined format println. So there is no function called println because we missed a T. So add the T and save it again with Control S. No squigglies. That means our program is probably good. So now we need to compile our program because all this is some text. A computer cannot directly read text and execute the instructions. So we need to compile it. So your terminal, when you open it up with Control backtick, should start out in the directory you need, the same directory your code is in. And now we can run the Go compiler on our code. And you can do that by typing go build and hit enter. And we got no errors. So if we type dir to list things again, we see there's a new file now called helloworld.exe. So that is an actual executable file that your computer can run. So the compiler has gone through this source code and turned it into machine code inside helloworld.exe. So you can run it, and there you go. It says hello world. All right, so now we have a working program that does something. Another way you can compile and run your code, that's sort of a shortcut, is you can say go run hello world.go. Just give it the file name you want to run. And that'll sort of compile and run it in one step. Just saves you some typing. Okay, so we've got this function main, which is a function we had to have. But you can make as many functions as you want, and you can call them whenever you want. So let's make a new one. And to make a function, it's the same way we made the main function. You start with func, and then give it a name. So let's make one called say hello. And we will have this print something as well. And then from our main function, we can call this function just by giving the same name and passing whatever arguments it needs. And this function does not need any arguments right now, so we don't have to pass it anything. We just open, close paren. So if we save that, control backtick, and run it again. And by the way, you can hit up arrow in a console or down arrow to go through previous things you did, so you don't have to type it again. We see that it says hello. So it's pretty simple. When this program runs, the first thing it does is it comes to the main function. It starts executing right here. And then it sees that you want to call the say hello function. And execution jumps up to the say hello function. And then it runs the print line function with the word hello, and that prints it to the screen. Then this function exits, and then this function exits, and it's done. So that's all that's happening. So functions can call other functions, like we're doing here. Functions can also have arguments. So maybe we don't want say hello to do the same thing every time. Maybe sometimes we want it to, maybe we want it to say hello to particular people. So to indicate that a function can take an argument, you start with the name of the argument. It can be anything you want. So let's actually use the word name here, because we're going to say hello to particular people. And you also need to give the argument a type. Go is a statically typed language, which means all of your variables and arguments have their types decided when it's compiled. This is different than some languages like JavaScript or Lisp, where types are usually decided at runtime. You don't have to provide them in your source code. So now we have a function, say hello, that requires that you pass it a string that is a name, or a string that we call it name. So to use that argument, we can just provide the name, and we have a plus operator available, which for strings just appends them. So we actually want a space between hello and name too, so we can do that, or more simply, we'll put a space after hello. And now we see that say hello's got an error. That's because say hello is defined to take a string argument, and we're not giving it one. So it is not happy. So we have to pass in a string here. So we can say Beverly. Squigglies are gone, so this is good. So if we run this program, we'll see it says hello Beverly, because we called the function with the argument, and it prints hello plus the argument. So now we've got something more flexible than we had before, because we can reuse this function over and over and over with as many names as we want. Okay? So functions can also be composed. And what that means is you can kind of take the results of one function and apply them to another. So I guess before we talk about that, we should talk about so someone's asking, is anyone having buffering issues? I am just seeing the say hello function. If you could provide more detail on what you're seeing that's wrong. Is the video not caught up with the sound? Anyone else having issues? No, no buffering, but I missed that compile command. One way you could compile is to type go build, and that will just build all of the source code in the directory. So that will create the executable. And you can also type go run, and then the name of your source file, and that will compile and run it. So if you're seeing the video stuttering and stopping occasionally, one thing you can do is turn down the quality if your internet connection is not handling it. I'll show how to do that real quick. So if you hover here and go to settings, quality, you could try turning that down, and that might help. It can make it hard to read though if you go too low. Let me know if that works out for you. Okay, so far the functions we have, they are just printing things to the screen, but they can also return things. And so we're going to start introducing variables. So there's a couple ways you could declare a variable in Go. You can use the var keyword and then pick a name. We'll call this first one x, and then you have to give it a type. So probably the most common type is an integer. So if you hit enter there, we now have a variable called x that is an integer. And we get an error because we've declared it, but we haven't used it anywhere. So the compiler will sort of let you know you've made a mistake in that case. But we can use it. And what we can do is say, let's give x a value. So we can say x equals 5. And then we can print it. So if we say go run hello world, we see 5. A shortcut you can use in Go, rather than doing this or this, is you can use the colon equal syntax. So if you just say x colon equal 5, what'll happen is it'll know that you mean to say, it's basically exactly equivalent to saying var x int equals 5. And the way it works is the compiler looks at this value 5. It knows that 5 is an integer, so it knows that x has to be an integer. So if you hover over x with your mouse, it'll actually tell you what it has inferred the type to be. And if we made this 5.0, we would see it's inferred to be a floating type. So some of the types that are built into the language are integer, which comes in various sizes. So there's int 16, int 32, int 32, int 64. And this just means that they can hold bigger and bigger numbers. So any number you store in a computer program, someone's asking that they say they don't get that error. Yeah, it could be that either the Go plugin's not installed or you haven't restarted VS Code yet. If you don't restart VS Code, it won't actually be active. Or maybe you haven't run the install all the tools. So if you right click, go to Go show all commands, and then go install update tools. If you haven't done that yet, it may not work. And you also have to save. It does that error checking when you save, not just as you type. Yeah, so when programs run, when they store numbers, it takes up a certain amount of space and memory. So you might just say, why not use int64 all the time, so you always have available, you can store numbers as big as you're ever going to need. But that takes up more space than an int16. So if you were storing something like someone's age, you might use the byte type. So a byte can be between negative 128 and positive 128. Probably never going to have ages bigger than that. So that would be like the smallest way in memory you could store an age. Other types, there's float 32, there's float 64. That's just two different sizes of floating point. So integers have to be, I think there's a comment. Integers have to be like whole numbers. 1, 2, 3. You can be -1, it can be 0. But you cannot store something like pi, 3.14159, in an integer. It just doesn't do that. These are types that your CPU and your computer actually knows how to do math with. And there's actual instructions that operate on integers, and they're different than instructions that operate on floating points. So you kind of want to use integers if you can, because those operations are faster. But if you need decimals, you need to use floating point. Along with sort of the number types, there's also strings. Yeah, for storing whatever text you want to do. And you can make your own types, which we'll get to later. So for now, let's just work with some integers. So let's say var x is an integer. And we're going to say it's equal to, let's say 10. So let's say that we're going to be doubling. We're going to be doubling numbers a lot. And so we want a function that will do that for us. So we can say function, call it times 2. And it'll take an integer. It'll take some number, that's an integer, and it will return a new integer. And this is how we indicate that it's going to return a value. So it's going to take in a number that's an integer, and it's going to return a number that's an integer. And all we're going to do is say return num times 2. And the way we can use it is we can say x equals times 2, typo. So now when we print it, we should expect to see 20. So control backtick, run it, and we get 20. And now functions can be composed, which means you can take the results of one function and apply them to the next. So let's make another function called +1. This will take an integer and return an integer. And it'll just return number +1. And so now if we wanted to double a number and then add 1, we could say +1 times 2 of x. And we run that, and we see 21. So what's happening here is we see that we're calling the +1 function, and we have to give it an argument. And the argument we've given it is times 2 of x. So before we could run +1, we've got to run times 2. So times 2 will run with x, double it, and return the result. So the result of that will be 20, which is what gets passed to +1, and you get x. And that's called composition when you do that. And obviously these examples are trivial. You don't really need to do this. But this is a powerful idea, which we'll see later. All right. Functions can take any number of arguments you want, not just one. So you could imagine a function called sumAll3. And this could take a, b, and c, which are all integers. And if your arguments are all the same type, you can use this shorthand syntax where you just a, comma, b, comma, c, and then int indicates that those are all three going to be integers. And it will return one integer. And then you could say return a plus b plus c. So any number of arguments you want is fine. And 1 minute, I'll be right back. And if you've got this going, you can experiment with some functions of your own. I'll be right back. All right, I'm back. Okay. All right. Another cool idea is that functions can call themselves. So let's give that a try. What would happen, for instance, if we made this function say hello, call itself? So let's give it a try. So we don't get any errors. All right. We see it saying hello everybody over and over and over and over and over and over. And this will go not quite forever, but it'll go for a long time saying hello everybody. And to cancel that, you can hit Control C a few times, and it'll quit. So what's happening here is we're calling say hello. It prints hello, and then it's calling itself. So the execution keeps kind of going in a circle. This can't quite go forever, um, because the way functions work is every time you call a function, a little bit of space is reserved in memory for it. So if you were to imagine this executing in memory, say hello gets called, and it's saving some data like the name, and it gets called again, and it's saving the name again. Right, and this goes on indefinitely. So you're kind of like allocating space for this name variable over and over and over and over because you've got one function running inside another, one running inside another. And eventually that'll run out of space and die unless your compiler is smart enough to kind of magically make that not happen, which Go doesn't do. So recursion is really cool. We're going to get to that again later, but you do have to understand there's a limitation sometimes to how deep it can go. So that's a function calling itself. You can play around with that and do some fun things. Okay. So let's try to make something that is actually a game. And we're going to learn about loops and flow control. So let's start with loops, which we're going to need to do the game we're going to do. So let's say that you wanted to say hello more than once, right? You wanted to do it 10, say 5 times, right? So you could say hello and then like copy and paste it, right? But maybe you don't know how many times you want to say hello ahead of time. Maybe you want to do it 1,000 times. You don't want to type it like that. So what you could do is use a loop. So in Go, there is only one keyword for loops, and it's called for. It doesn't make a lot of sense if you're not a programmer, but a lot of languages use for as the for loop, as a loop keyword. So if you did just the word for with nothing else added, this will go forever. This is an infinite loop. Sometimes you do want to do this because there is a way to break out of it. But right now, this would just go forever. And this really will run forever until you turn your computer off because there's no space being built up in memory as you go. It just runs it once, then again, and again, and again. So this could run forever. But let's say we only want to have it run a certain number of times. What we could do is you can create a variable the first time you run your for loop. We're going to just call it I. That's a convention when you have loops to use the letter I as the sort of counting variable. And we'll start it out at 0. Then you do a semicolon. and you put a condition in, and this is something that has to be true or the loop's going to stop. So we're going to say that I has to be less than 5. And do a semicolon again, and then the last thing you tell it is what to do at the end of every loop. And what we're going to do at the end of every loop is add 1 to I. All right, so we're going to start, when we first start the loop, we're going to set I to 0. The I has to be less than 5, or we're going to stop looping. And every time we're done with a loop, we're going to add 1 to I. So let's see what happens. So now we get 1, 2, 3, 4, 5. All right. Now to see what's actually going on here, we can also print out I to kind of follow what's going on. Oh, say hello cannot take an extra parameter, but what we can do, can we do that? No, we can't do that. But we could do this. Do format.println, which can take a string and a number. So now each time this loop runs, it's going to print out what I was in that instance of the loop. So let's run it, and we'll see hello 0, hello 1, hello 2, hello 3, hello 4. Now right after hello 4 printed, it's going to add 1 to I, which means I is equal to 5. And it's going to go back up here and check this condition. Is I less than 5? It's not, because it's equal to 5. And so the loop stops, and then the program ends. Now if we wanted this to be more flexible, because this is always just going to do 5 times, we could make a function, call it say hello lots, and it'll take a name like before, and also a number. So we'll call it num, make that an integer. And then we could say for I starts at 0, and while I is less than num, right, this is the parameter that gets passed in, I equals I plus 1. Someone says they get an error. Where are you getting an error? If you give me some more detail, I might be able to tell what's going wrong. Cannot convert type. Where did it say that? Was this when you were trying to do the loop from 0 to 5? Name to type int. Did you change this to a print line instead of say hello? If you're trying to call save hello with this, it's not going to work. If you want to copy and paste the line that's got the error into chat, that might work. Then we can take a look at it. Cool. So you'll see like that kind of thing happens all the time in programming. You'll look at something and you're sure it's right, and there's a comma missing, or a space missing, or a semicolon missing, or closing brace missing. Um, so you usually have to trust when the compiler tells you there's an error, there almost always really is, and just really kind of go character by character and check things to be sure it's correct. Happens all the time, no matter how experienced you get. All right, so back to say hello lots. We've got this new for loop. So instead of us checking to see if I is less than 5, we're checking to see if I is less than num. So this gives us some flexibility. Now we've got a function that can say hello however many times we want. So we can call it one time. Sorry, microphone just shut off. Should be back now. So we can say hello lots to Jack 5 times, or say hello lots to Beverly 10 times. And let's give it a try. All right, so I'll make this bigger. So we can say we got 5 hello Jacks, 5 hello Beverlys. And we could use a space there so it'll look nicer. All right. So that's loops. And we use these constantly in programming, all the time. And then the next idea, and this is kind of the final idea in programming that is sort of universal, is flow control. So it's pretty simple, really. Sometimes we want to do one thing or the other, depending on certain conditions. So let's start with a variable. We'll call it x, and we'll just set it equal to 5. Let's say that let's say that sometimes we want to say hello to Jack, and sometimes we want to say hello to Beverly. And let's say that if x is less than 5, then we want to say hello to Beverly. Else, we want to say hello to Jack. Now in this case, x is hard-coded to be 5, but it could be something that the user inputs, right? If the user inputted a value, we wouldn't know what it is when we're compiling it. We have to wait till runtime. So if we run this now, it says Jack because x is not less than 5. We change this to 1. Now it says Beverly. So this idea is called flow control, and this kind of flow control is called an if statement. So these can work lots of different ways. We could just say this, right? If x is less than 5, say hello to Beverly, right? So right now it is, so it says it. And now it isn't, so nothing happens at all. You can have, like I had before, an else statement. So if your if statement is not true, it could do one thing. So yeah, if this is true, it'll do it. But if that's not true, otherwise do this. It's kind of like a default. And you can also have an else if. So so this is with else if, you can chain these together as long as you want, right? So you could say maybe something like this. If x equals 1, else if x equals 2, else if x equals 3, right? You can go on indefinitely with any else ifs as you want. And this equal syntax, if you want to compare whether two things are equal, you use 2 equals. And if you want to set something equal, you use 1 equal. This is an old convention, and it's just to disambiguate the setting of a value versus comparing two values. So, and that's another common mistake to make is you forget to put two equals, and you'll notice you get an error because it knows that you mean to compare things rather than set them. All right, so you can chain these together as many as you want. So if we run it right now, it says hello Beverly because x was 1. Set x to 3. It says hello subpop. If we set x to 4, none of these things match, so it doesn't do anything. So it's common to have an else to sort of handle cases you didn't think of, or as a shortcut. Like in this case, we might say, unexpected. Right, so now we get that. All right, so if statements and for loops and functions is pretty much what programming is about. And this gives us enough knowledge to sort of make our first game, which the first game we're going to do, we're probably going to do it next time because we're getting to 1 hour now. It's called Guess the Number. And it's a silly, simple text-based game, but it's going to be one where the computer comes up with a number and the user has to try to guess it, and the computer will tell them if they're too high or too low. And so you have to sort of narrow down what the guess is. And so all we're going to need to do that is flow control, some if statements, and some loops. The loop will let the user keep guessing. So that's what we're going to work on next time. If you want to do some practice, and I recommend that you do, you could try some things out on your own. Some things you can try are you want to make some of your own functions to play with to get used to how the syntax works. Try writing a function that takes Fahrenheit as input. So and returns Celsius. So you could like look up the conversion for Fahrenheit to Celsius and try to encode that in a function. And you have all of the regular math operations available to you. So you can say 1 + 1, multiplication is the star symbol, division is the slash, subtraction. All those things will work on numbers and variables. And you can work on trying to make a function that will convert Fahrenheit to Celsius. And then come up with some of your own. And if you come up with something cool, we can show it on stream next time too. Subpop asked why the colon. Do you mean in the for loop why are there semicolons, or do you mean here? So yeah, I think you mean here for the x equals. So this colon equals is a special syntax for when you haven't already declared a variable. So this basically means declare x as and then set it equal to 5. Yeah. So if you have already declared the variable, this would be an error because it's like you're saying var x equals 6, and you already have an x, so you can't do that. So once a variable is declared, you just use 1 equal, and that will just change the value stored in x. So that's all. It's just like a shorthand. You could never ever use that if you wanted to, and just always say, right? And this gives you green squigglies because it knows it's an integer already. It's just telling it you can make it shorter, but you don't have to. That will still run. Okay, any other questions or difficulties that anyone's had, or critiques? All right. So, like I said, this is a test stream, so feel free to, send me an email or get in touch with me. Let me know if there's things that were no good or could be better. Um, if and when we do another one, we'll do the guess the number game, and absolutely just play around with this. Try to make your own functions, experiment with things. When you get errors, the compiler will tell you kind of what's wrong, and you can usually figure it out what's going on. And also keep in mind you can always go look at the documentation. So if you go to the golang.org website and then documents, they've got getting started guides, a tour of Go. Package documentation is how you can see all the libraries that are included with Go and what functions are available in them. So you can play around with those things and see what you can figure out. All right, that is all for now, and I'll see you all next time. Thanks.